Okay. So, all right. So complex numbers or imaginary numbers. So, okay. So take a look. Until now, right, we knew that, okay, the square root of 4 is how much? 2. But then if you had the square root of -4, we're like, oh, no, no, we can't do that. That doesn't work, right? Until today, right? And until today, all of the numbers that you have encountered have all been real numbers, right? Remember in the beginning of the year when we were classifying numbers, we were like, okay, it's all going to be real, 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 real. And then in addition, this, this, this. Well, now it's the not real part, okay? So where are imaginary numbers used? Imaginary numbers are used in electricity and electrical engineering, right? So if you have a circuit, for example, in a circuit, you have a capacitor, you have a power source, you have a resistor. And when you add up all of those, quantities, all of the resistances are imaginary numbers. They're used in physics, in light waves, in periodic, so a lot of places. Okay, so without further ado, what is this imaginary number? First of all, the imaginary number is always written as an italicized lowercase I. Okay, never a capital letter, right? And I is equal to the square root of -1. Okay? If you have pure imaginary numbers, they look like this, like 5i, -2/3i, I root 3, and so on. Okay? Those are all imaginary numbers. Okay, so how do we simplify how do we use imaginary numbers? So take a look. I have the square root of -9. And until now, it was like, oh, no, no. You can't have the square root of a negative number, right? Well, right now, first time ever, we can. So anytime you have a negative inside the square root, it comes out as an I. So this will be I, okay, the negative comes out as an I, so it'll be I root 9. And what's root 9? 3. So this will be 3 times I. Okay? So same thing here. The negative will sort of come out as an I. So you have I root 64. What's root 64? 8. So this is 8I. Okay? Now, you can just do it in your mind, right? You go, okay, the square root of 64 is 8, but there is a negative, it's 8I, right? You don't have to go in multiple steps. I just do that so everybody can follow what I'm thinking, okay? Yeah.
So since it's italicized, like is there a specific way you have to write it, like when you're writing by hand, or can you just do a normal I?
You could do a normal I, like some people do I like that, but make sure like it looks like an I and it doesn't look like an 81. You know what I mean?
Well,
Yeah. Right. So yeah, like sometimes when I'm writing, I don't always dot my I's. So my imaginary number I always looks different. Okay. Okay, so here, this will be I root 18. And now we need to simplify the 18. To simplify the 18, we need to do a factor tree, right? So just think of anything you can divide 18 by. What can we divide 18 by? What two numbers make up 18? 9 and 2. All right, let's do 2 and 9. And then the 9, we can go further into 3 and 3. Okay, the way I like to think of this is, imagine that 18 is in jail, right? And these are all the numbers. Any of these ending numbers, any of them that can find a partner, can escape from jail. So the 3 finds a partner, can escape from jail. That poor lonely 2 stays inside. So this will be 3i root 2, right? The 3 comes out, the 2 stays in. And so when you have a number and an I, we normally write the number first, then the I. If there is a square root, we put the I right before the square root, okay? All right, so here, always take care of your negative first. The negative will translate to an I. And then I've got the 125. I can divide this by 5 and 25. Then this will be 5 and 5. So these two come out as a single 5. The other one stays in. So it's 5i root 5. Okay? Okay, now. All right, so I is to the power of 1 is just I. Okay, this you have to know. Oops, I guess I can't do that. This you have to know like your life depended on it. Memorize that one fact, not the entire chart, just this one fact. Memorize it. Okay? I squared is -1. So if you're walking down, somewhere down one of these hallways, and if I happen to walk past you, if I tap you on the shoulder and go, hey, what's I squared? What should you tell me? -1. I squared is always -1. Okay? So I cubed, what's I cubed? How many i's is in I cubed? 3. So this is like I squared times I, right? What's I squared? -1 times I. So it's -I. Okay? Okay, I to the 4, how many i's are there? 4. We always split these up in terms of the 2. Okay? So I have I squared. That's a total of 4 i's, right? I squared is -1. The other I squared is -1. So together, this makes 1. Okay, so look, when the exponent is 1, you have I. When the exponent is 2, -1. Then -I, then 1. Okay, here, let's split it in terms of 2's. This is I to the 5. There are 5 i's. So I squared, and how many i's do I have left? 1 more. So I squared is -1. I squared is -1 times I. How much is that? Negative or positive? Positive 1i. Okay? So look, let's split this up by 2's. I squared, I squared, I squared. Right? 2, 4, 6. Each I squared is -1. So -1, -1, -1. How much is it all together? -1. Okay? Let's do the same thing here. I squared, I squared, I squared, 1. Is that right? 2, 4, 6, 7? Yep. Okay. So I have I squared is -1, -1, -1 times an I. So are all these -1s going to end up as +1 or -1? -1, because there's 3 of them. -1 times I, -I. Here, I squared, I squared, I squared, I squared, right? 2, 4, 6, 8. Each of these is -1. How much does that end with? 1. Okay? So now, hang on. Look. What did we get here? As we increase the exponents, right? I to the 1, 2, 3, 4, 5, 6, 7, 8. Look at the values. We have I -1, -I, 1. And then look here. I -1, -I, 1. Do you see how it's a pattern that always repeats? So every 4, the pattern will always repeat. Okay? All right. So what's I squared? Okay, one more time. What's I squared? Okay, so here. How are we going to multiply this? Okay, so I have 3i times 4i. We kind of do this just like any other variable. You take care of the 3 times 4 first. That gives you 12. And then I times I is I squared. So this is 12 times -1, -12. Cool? So anytime you see an I squared, you change it to a -1. Okay. This one. We have to simplify roots first. Okay, so what will this be? The I will come out, so you have root 12. The I will come out, so you have root 2. Can the root 2 simplify anymore? No, but the root 12 can, right? So let's do the 12. What do you guys want to split it into? 6 and 2. And the 6? 3 and 2. These 2's come out. So I have 2I root 3 times I root 2. Okay? Now, these i's will be I squared, right? So this is 2I squared. And then these we can multiply with each other. What do I get when I multiply those with each other? Square root of 3 times 2 will be 6. Okay, so what's I squared? What's I squared? -1. So 2I squared is -2. Root 6. Okay, so it's a process. Okay, square root property. We've been doing this since, before. So basically, this is when you can take a square root of both sides, right? Okay, so take a look here. 4x squared equals to -100. What do we do first to solve for x? Divide by 4. So x squared is -25. Now, take a square root, take a square root. X is, if you take a square root of both sides, what happens? What do you add? Plus or minus. Okay, now, this is I, and what's root 25? 5. So it's plus or minus 5i. Okay, so always take care of the negative in the root first. That comes out as an I. The 25 gives you a 5, so it's 5i. Okay? All right, let's do the next one. Let's move the 20 to the other side. Okay? Now what? What would you do next? Divide by 5. So x squared is -4. Take a square root. X is plus or minus. What happens to the negative? Comes out as an I. And then, right, the 4 is a 2, so it's plus or minus 2i. You would never write it as I2. That just seems silly. It's like writing, like, instead of 3x, if you write x3, that just looks so off. Okay. Okay, a couple more. So this is a purely imaginary number. It's just 2i, 3i. It's just imaginary. Sometimes, however, you can have a real part attached to an imaginary part. We call that a complex number, okay? And it's written like a plus bi. So for example, if I have 3 plus 5i, that's a complex number. This 3 is real, the 5i is imaginary. Together, it's complex, okay? It's like like a mixed pairing or something, okay? The real and the imaginary are not like terms, and they cannot be combined. So you can't make it like 8 or 8i. Cool? Okay, they're literally like, they're like not buddies, but they're civil. Like that's exactly what they are. We always keep them just a little separated. Like they go along, but they're not buddies. Okay? Okay. So with this, we do like terms, right?